So we are now finishing up the chapter and the last thing for the semester with section 12.9 of your book, and it's talking about the shell model of the atom. Okay, easy peasy thing to do. It's similar to Bohr, but Bohr, if you remember, only was dealing with one electron in his model. This has places reserved for all of the electrons in all the atoms, not just one. First, we need to define a few things. What's a shell? A shell is a region of space where electrons can reside. As shells get bigger, they can hold more electrons. This makes sense because they're going from tiny little things to bigger and bigger. As there's more volume for the shell, there's more room in them for electrons. And the electrons have room to be away from each other because they're all negatively charged, and negatively charged species repel each other. So as shells get bigger, they can hold more electrons because the electrons are farther apart. Now, there is a rule to knowing how many electrons go in each shell. For the n equals 1 shell, which is closest to the nucleus, this shell can only hold 2 electrons. Remember, we're using E minus for electron. When you go out to n equals 2 and n equals 3, the next shell's larger and slightly farther away from the nucleus, they can each hold 8 electrons. So n equals 2 can hold 8, n equals 3 can hold 8. If you go out to n equals 4 and n equals 5, farther away from the nucleus yet, each of these shells can hold 18 electrons. So n equals 4 can hold 18, n equals 5 can hold 18. The last shells that we look at, n equals 6 and n equals 7, can each hold 32 electrons. So 32 and n equals 6, 32 and n equals 7. 1 through 7 correspond, first of all, these are the maximum numbers of electrons in each shell. If you don't have quite enough to fill them up, say you'd fill this one up all the way, and then you might only have 4 electrons in total. Well, 2 plus 2, n equals 2, would only have 2 in it. So each shell is filled before beginning to populate another, which was what I was talking about, and we'll see in a minute from diagrams. Another thing to remember is each shell corresponds to a period on the periodic table. The periods were listed 1, 2, 3, 4, 5, 6, 7, like that, and they go across, like so. You guys get what I'm doing, right? Those are badly drawn arrows. So the n equals 1 shell corresponds to period 1, n equals 2, period 3, n equals 6, period 6, n equals 7 shell, period 7. That's where those numbers come from. So if you look at the n equals 1 shell, and these are much more nicely illustrated in your book, you have the nucleus here. For the hydrogen atom, you have only 1 electron, and your book puts it up there on top. For helium, here's the nucleus. Helium has 2 electrons, and your textbook puts them here and here. They're paired, which is kind of an important thing. Electrons like to be paired. So if we go down to n equals 2, we've got nuclei that I didn't draw and really badly drawn shells. They keep getting smaller. But n equals 2, we have helium, lithium, and boron, beryllium, then boron. Anyway, we have 3 electrons here. 2 go in this shell, the n equals 1 shell, and 1 goes out here in the n equals 2 shell. With beryllium, you've got 4 electrons. You again have 2 here in the n equals 1 shell, and in your book, they put them across from each other. They're not paired yet. When you go to boron, you've got 5 electrons. 2 are paired in the n equals 1 shell. Then you go 1, 2, 3. What's after boron? Nitrogen? Carbon, right, I knew that. With carbon, there are 6 electrons. These 2 are paired at the n equals 1 shell, and we have 3, 4, 5, and 6. If you go on to nitrogen, which has 7 electrons, you have 2 that are paired in the n equals 1 shell. We've got 5 left to deal with, so we go 1, 2, 3, 4, and then we have to pair any one of these 4. I think your book does this one first, But in reality, it doesn't matter. You just pair them, one at a time until they're all the way filled. So if you went up to n equals 10, okay, which would be neon, we've got 7, we would then go 8, 9, 10 until they were all filled, and then we'd go up to another shell, the n equals 3 shell. So you guys are going to practice on that, and you'll have these guys on your test. And that's it for the semester. Yay!